Okay, two goals: converting in and out of scientific notation and performing operations in them. By operations, I mean adding, subtracting, multiplying, and dividing. So we should feel pretty comfortable with exponent operations, which is similar to what we're doing here. It also connects to how we were converting rational numbers from fractions to decimals using the 10 rule. So big numbers are great for scientific notation. Small numbers are great for scientific notation. So you can take this, scientific notation must fall between 1 and 10. That's what the A has to be. Don't touch that, please. So I'm going to take my 9, 4, and then a bunch of zeros, and I know that my decimal place needs to land here in order for my A to be between 1 and 10. So this is going to be 9.4 times, how many 10s would I have to multiply by to get back to this? 3, 6, 9, 10, 11. Multiply it by 11 sets of 10. Or sometimes really small numbers like this. So where would my decimal place have to land? Right there. So I'm going to have to go 1, 2, 3, 4 times over. 2.3047 times 10 to the, well, I'm dividing by 10, so times 10 to the negative fourth. Negative fourth. You're okay. Okay, one more here. Really big number. Find where that decimal place lands here. So it's going to be 2.76892. And then the rest of these digits would be irrelevant. We just need to use them to help us count. There, I'll refocus it for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal place shifts. Okay. Try to do this one on your own. If there's 13 zeros from the decimal place until you get to the 2, what would this one look like in scientific notation? Okay. Let's do the other way. If there's 18 tens, that means my decimal place needs to be moved 18 times. So I would have 2, 7, 8, that's 1, 2, and then 16 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I like to write them in threes because it's easy to count, but it's kind of hard to see where your commas would go. There, there, 1, 2, 3, there, there, 1, 2, 3, there, there. Okay. 10 to the negative 8th mean we're going to be moving our decimal place the other way because this number must be significantly smaller than what it's noted as. Try that one on your own. Okay. Operations on numbers in scientific notation. It's easier than multiplying with all these zeros to sometimes put them into scientific notation and then compute what your answer should be. So 6.4, 1, 2, 3, 4 times did we have to move our decimal place, times 2.536 times 10 to the 9th. Now I'm not expecting that you do these in your head, so you might want to get out your handy dandy calculator. Handy dandy calculator. I'll use my big one here, and I'm going to say 6.4 multiplied by 2.5 equals 16. Oh, how convenient. So 16 times 10 to the exponent operations, we just add our term in the air, 10 to the 13th, but 16 isn't in scientific notation, so one last step here where we convert it over. Times 10 to the 14th, because we had to add one more 10 into our multiplication, or multiply one more 10 in. Here's one that's dividing, so 7.8 8, 1, 2, 3, 4, 5, 6, 7, 10 to the negative 7th. And then 1.2 times 10 to the 3, 6, 9 again. 9 like up here, not 9 like here. 10 to the negative 9th. Okay. Use our calculator. You don't need to do that by hand unless you really want to. So 7.8 divided by 1.2 equals 6.5. That's cool because we won't have to do any further conversion. So 6.5 times, remember we subtract our exponents here. So negative 7 minus negative 9, this becomes plus plus, is a 2. So this is going to simplify to 10 to the 2nd. Okay, this one down here, this last one, is extra weird because we've got all these and we're doing a cube root. So it seems like something that might be sort of counterintuitive, but we have something that we can break up. Maybe not scientific operations, but look, I have a 27 there, right? And if I'm talking about cube roots, 27 is a perfect cube. So I can rewrite this as the cube root of 27 times 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Okay, well, the cube root of 27 is just 3, and then if I'm going to write this out, or we can use our exponent rules, 10 to the 9th in groups of 3, you would have 10 to the 3rd, 10 to the 3rd, and 10 to the 3rd. Those would add up to make 9. So I have one group of 10 to the 3rd, two groups of 10 to the 3rd, three groups of 10 to the 3rd. So that means I can take it out times 10 to the 3rd. So what does this equal? Handy dandy, 3,000.